You might correct it on the back. Write the problem, then show your steps all the way through. You still hadn't gotten at least 7 right, and we're still going. So on number 1, the rule here when you have like bases is to add the exponents together. So the base doesn't change. The exponent would be 2 plus -4, which would be 3 to the -2 power. You're not supposed to leave the exponent negative. That doesn't mean you just get to erase the negative sign. You can write it as a fraction. That still doesn't change the sign of the exponent. But when you take it from the numerator to the denominator, then the exponent can change from a negative to a positive. But not until then. If you wanted to keep going, you can call it 1 over 9, or you can just leave it like that. In number 2, where we have a power to a power, the base doesn't change, but the exponents are multiplied together, and you give it 2 to the 6. You can leave it like that. You don't have to figure out what 2 to the 6th is. Number 3, in division, your rule is when you have like bases, you'll subtract the exponents. The base stays the same, 2 minus 6, which would be 2, -4. You want to write it as a fraction, which is like this. Now you could have reduced them at that point like we will in the problems later on. Both of these will cancel with 2 of those 6. And so all of the 2's in the numerator will get canceled out. But you need to leave a 1. When all of these cancel, when those 2 cancel with 2 of those 6, you get 2 to the 0 power, which is 1. So you need to leave a placeholder of 1 because this 2 to the 4th is still in the denominator. These 2 cancel out with 2 of those 6. So that's another way you could have approached that problem. All right, number 4, when you have an exponent outside of a fraction, that exponent gets applied and distributed to the numerator and the denominator. So you get 1 to the -3rd over 3 to the -3rd. But we don't leave the exponents negative. So we're going to take the 1 to the -3rd and move it to the bottom, 3 to the -3rd and move it to the top. So it'll become 3 to the +3rd over 1 to the +3rd. 1 to the +3rd, we should know that that's 1 times 1 times 1 is 1. Even if we don't know what 3 to the 3rd is. And anything over 1, you have a denominator of 1, you can leave it off. Just as easy as you can add it if you need 1 in the denominator, if you needed a fraction. Number 5, we have 4x inside parentheses with a squared outside. That means that 2 gets applied and distributed to both of the factors inside. So it becomes 4 squared x squared, which is 16. 4 squared is 16 x squared. We can do 4 times 4 without a calculator. Number 6, x to the 0 is 1. X to the 0, anything to the 0 power is 1. So this factor is totally removed, the x included. You take this out and put that in its place. 1, y, negative 3. There is no more x. And 1 times anything, you don't have to write the 1. Now we just need to deal with this y to the negative third. We make it a fraction. It's y to the negative third over 1. And then we move it to the denominator so that that 3 is now positive. But the place value at the top is 1. Just to maintain it a fraction. But you have to have something up there, and 1 is what you need. You don't want to put 0 up there, the whole thing is 0. Number 7. If there's different ways that you can go about doing these types of problems. You deal with if you can separate it out and make it, separate it out so you have 7, 2, and then x negative 2, y to the third, then maybe you can see some things that can cancel. Okay? We have a negative exponent here, so it would be better if we wrote that, if we took that and moved it to the denominator. And made it x squared. And so if you had an x squared and an x to the first power, what would that become in the denominator? The third. 7, 2, the x in the numerator is gone completely. Now, another way you can look at it is, okay, we have x to the negative 2 over x to the first. X negative 2 minus, when it's division, you subtract the exponents. Well, that would make it x to the negative third in the numerator, and then we'd move it to the denominator to make it positive. It's another way you can look at it. Then you deal with the y's. You have more in the denominator than you do in the numerator. So you have y to the first in the numerator, y to the third in the denominator. So that means all of the y's in the numerator are going to get canceled out. 3, you cancel out one of them, you have 2 left. 3 minus 1 is 2. You're done. All right, number 8. This negative sign, the negative sign on the 3 does not matter. That doesn't change. It's only the negatives and the exponents that you need to worry about. So if we move all of the ones that have negative exponents, if we move them so that we don't have any negative exponents, and then try to rework the problem, rewrite it and rework it, let's see what we get. This first fraction, we have a negative 3, we have an x squared, and then this guy is going to move to the top, x to the first, positive 1 now. In the bottom, 2, y to the third, they didn't move. Then in the next fraction, we have x to the negative 1 over 2, y to the negative 1. The 2 is not going to move. The y to the negative 1 will move up. The x to the negative 1 will move down. They'll just take each other's place. It'll be y to the positive 1 and x to the positive 1. And we don't have to write the 1s above these as exponents, but I am just to help you out. So then when we multiply the two fractions together, in the top, we get all of that multiplied together. It's negative 3, x to the third, y to the first. And in the bottom, it's 2, y to the third, x to the first. We're not reduced. If we have an x in the numerator and an x in the denominator, there's some reducing we can do. So Let's look at the x's. There's 3 multiplied together on top, and there's 1 on bottom. 3 minus 1 is 2. So it's going to be x to the 2. With the y's, the 2 doesn't change, but the y's, you have 3 in the denominator, and y to the first in the numerator. So 3 minus 1, again, is y to the 2, or y squared. There's your final answer. So you get, so once you do that, he's gone there. And let's multiply across and see what we get. We get 5 times negative 2, we are negative 10. The coefficients can multiply together. X squared, we got another x hiding in there. X squared times x is x to the third. Y, we don't have another y, so then the 6 in the bottom, x to the third, and y times y is y squared. Now let's try to reduce. The 10 and 6 can reduce to 5 and 3. Negative sign doesn't go anywhere. The x to the third over x to the third, anything divided by itself, all 3 of those cancel with all 3 of those. So we're left with 1 over 1. We won't even write a 1. And then y over y squared. All of these will cancel. All the ones on top will cancel. And 1 of the 2 will cancel on bottom, so you're just left with y. Get the right side set up to look like the left side, except for the exponents. So when you're dividing and you have like bases, the 7s are the same, then that's 7 to the x minus 9 power. And that's equal to 7 to the 5th. So what does x have to be to get the same numbers in the top? 14 minus 9 is 5. The other way, you can come down, and if you can't do that in your head, you can set up an equation with the exponents, add 9 to both sides, get 14.